Let P1, X1, Y1, Z1, and P2, X2, Y2, Z2, be 2 points. 2 points in this place. We define the distance between these 2 points this way. So suppose this is P1, this is P2. For example, we start from P1, the initial point, from San Francisco, right, from San Jose to San Francisco. So this is your initial point. Going to San Francisco, this is your terminal point. So we're actually constructing a vector. The distance between these 2 points actually give you the length of this vector. The distance between these 2 points is denoted this way. We use absolute value sign, absolute value. P1, P2, and we use an arrow or just a nice line on top of P1 and P2 to show that, hey, we're finding the distance between these 2 points. It's also denoted by D as the distance as well. This is equal to square root of the difference between x value squared, x2 minus x1 squared, plus the difference in y value squared, y2 minus y1 squared, plus the difference in z values, z2 minus z1 squared. So here you have your vector. This vector for P1, P2 is defined this way. X2 minus X1, Y2 minus Y1, and Z2 minus Z1. Then you find the distance between these 2 points or the length of this vector. The vector has first coordinate, second coordinate, x2 minus x1, y2 minus y1, and z2 minus z. The length of the vector or the distance between these 2 points is defined as the square root of this point. Okay, suppose we have 2 points and we want to find the distance between them. Let P1 be defined as -2, -1, and 7. And P2 is defined as 1, -3, and 5. The distance between these two, for the absolute value of P1, P2, for B is equal to square root of 1 minus 2 squared plus -3 minus 1 squared plus 5 minus 7 squared. After doing the algebra, this is equal to square root of 1 plus 4 plus 4, which is equal to 3. For example, the distance is equal to 3. Perfect. So let us continue. There is a question. How do we define equation of a sphere using what just we learned? The distance between 2 points. So this is a question. The question says, how to write equation of a sphere using the distance. How we define a sphere? Sphere is a set of points in the space such that those points all have the exact same distance from a fixed point. So a sphere is the set of all points in the space with the exact same distance from a fixed point. So we're going to fix a point like C, HKM. Let's see, HKL. A fixed point. So this is your C, HK. This is a point in the space. The set of all points, these points with the same distance. So the same distance, another point. These are random points with the same distance from the fixed point, C. Another point. There are many of them. We cannot list all of them. That's why we're interested in writing a formula. D has the distance, D has the distance, and the rest of them. So the set of all points, which point? Take a random point. Suppose we take this point. X, Y, and Z. Such that the distance to that fixed point is fixed. So we learn that the distance is equal to the square root of the distance between these 2 points, x minus h squared plus y minus k squared plus z minus L squared. The distance between these points and that fixed point is d. It's fixed. So we can square both sides. D squared is equal to x minus h squared plus y minus k squared plus z minus L squared. We usually denote d by r or the radius. So the radius squared is equal to x minus h squared plus y minus k squared plus z minus L squared. The center of your sphere is the point C, H, K, and L, and the radius is R. If you want to visualize this, you get your x-axis, you get your y-axis, and you get your z-axis, and this is your sphere. This is a unity sphere, for example, with origin as the center. In this case, your H, K, and L are equal to 0. Again, recall that we define a circle this way. X minus h squared plus y minus k squared equals to r squared. This is just a circle in x, y plane. So in x, Y plane. When we don't have any Z, it means that we're working with a circle. That's the justice. And suppose this is the center of your circle, H and Q. And this is your radius. So when you're talking about the circle, circle is the projection of the sphere in XY plane. Circle is the projection of sphere. When you're talking about sphere, it means that you have to include Z as well. Of sphere in XY plane, or if you are working with other planes like XZ or YZ, just saying that, hey, that's the projection of sphere on those planes, two-dimensional. Now remember that it doesn't include the inner points. It just includes all the values on the circle.